Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 77. And it says the current through the 4 kilo ohm resistor, which is this one, you can't read my handwriting very well, is given as, let me write, I4 kilo ohm resistor is given by 3.1 milliamps. Okay, and it says what is the terminal voltage of VBA. Okay, so, and it says there are two answers. Why? Okay, so first we need to think about this. Why would there be two answers? Well, it's because we don't know which direction the given current is flowing. This current could be flowing to the right, could be flowing to the left. So if we assume the current is to the right, so let's do that. Let's just start out in two cases, right? So we're going to assume that I4 is to the right at 3.1 milliamps. So that means I4 is coming to the right. This is I4. Here is I8. And then here is I, such that I is coming around this way. So the voltage across the 4 kilo ohm resistor is just given by Ohm's law. So that's V equals IR, which is 3.1 milliamps times 4 kilo ohms. And that comes out to being 12.4 volts. So this is the voltage across the 4 kilo ohm resistor. And the voltage drop across the 8 kilo ohm resistor must be the same. But we know the current's going to be different. So this also equals V8. But I8 is given by V across 8 over 8 kilo ohm resistor. So this is 12.4 volts over 8 kilo ohms. And that comes out to being, oops, not 0, comes out to being 1.55 times 10 to the negative 3 amps. Okay, so that means now we know that the current splits here at the parallel section such that I is equal to I4 plus I8. So this is equal to 4.65 milliamps. That's the total current. So now we just have to use this to find the terminal voltage of the battery. To do that, we just write a loop equation. So let's go ahead and write the loop here. Using Kirchhoff's law, we know that VAB minus 5 kilo ohm times I minus 12.4 volts minus 12 volts minus, we did 12.4 instead of using I times the resistor because this is in parallel, so that's how we did that. Sorry for skip over that too fast. And then lastly, we have this 1 ohm resistor. 1 ohm times I. And this all equals 0 because we're going around in a full loop. So from this, we can just solve for what VAB is. So VAB equals, we just plug everything in. And this is 47.65 volts, or roughly 48 volts. Okay, so this is answer 1. Now, in blue, let's figure out if the current is going the other way. So we now have a counterclockwise current here. So now if we go this way with the current, if the current's to the left, the voltage drop across the parallel combination of resistors is still 12.4 volts. So we still have V4 equals VA equals 12.4 volts. But with the opposite orientation, yeah, of course. So now we just have to start a again, a loop equation, but going in the opposite direction. So if we go in the opposite direction here, we can then still start with VAB, but now we flip the signs on our rest of our equation. Except for the second battery, same direction, same orientation as the first battery. So that's the two things that don't flip signs are these two terms because they're the battery terms. And let's add in the 1 times I. And I did not flip the sign on that one. Okay, this equals 0. Again, we know everything except for VAB, so we just plug this in and solve for it. And we should get a VAB of negative 23.65 volts, or roughly negative 24 volts. And this is our second answer if the current is going to the left. Awesome. There it is.